Right, hey everybody. Hope everyone's having a good Friday so far. Mine's been pretty good. I'm excited about today. So, I've been talking about Friday streams. I'm going to try to make smaller, well, basically a self-contained project just on Friday. And for instance, today we're going to be working on making a 2D platformer with raycasting in Unity. And I hope that by the end of the stream today we'll have finished all these goals. But first of all, I guess let's go ahead and jump right into it. So I set up some art here. This is just a simple Unity project. I haven't really done much except pull in some assets. And we're going to go ahead and set up a few platforms here for our character. This sliced sprite, and if you've never played around with them in Unity, it's really nice. You can see how the borders are staying nice and crisp. And I'll just pull this out here. Actually, no, the width will be 20. Let's make it a little longer, I guess, so you don't see the borders right there. Height does not make much difference. This will just be the bottom platform. Okay, and now we need to add a box collider 2D. It doesn't, okay, that's a little bit of a shame. It doesn't automatically resize. You can see on the editor over here, the green outline is the collider. So we'll just create it ourselves. We already know the size is 21 by 3, and now it will match the sprite. And go ahead and change this material so it'll look crisper. Okay, and then we'll have our player character. Let's call this bottom platform. Oh, actually, before we do that, we should make a collider that just rings the edge of the screen so that our player character can't get out. So we'll just call this world boundary. And this will be set to 0, 0 in Unity. And this time, we don't want to use a box collider because we'll be moving around inside. So what you need to do is use an edge collider. And okay, we can see, well, the camera is kind of masking it, but you can see this green line is where the collider is at this moment. But instead we'll want 4 points, and our world is 20 units wide by 15 high, so the first point will be at -10, -7.5. And then we'll just go around clockwise. And then next one's at 10 and 7.5. And then finally 10 and -7.5. We can see now on the screen. Oh, well, actually, it doesn't do the bottom, but that's okay because we have this other collider there. So yeah, that works out fine. I guess if we want to do the bottom, we need, of course, one more point to close it up right there. Okay, so now let's add our character. Okay, and this will just have... Okay, so first I'm going to show kind of a basic character using Unity's built-in physics, and then why that's not the best idea for a platformer. So with built-in physics, you need a rigid body 2D, and then a box collider, or any kind of collider you want. And the reason you need a rigid body is because when you're using Unity's default physics, adding a rigid body means that Unity will be prepared for this object moving a lot. For instance, these platforms are never going to move, so Unity does some optimizations for that. And then so we can actually see what's going on here, we'll add a sprite renderer. Again, I'll change the material. And we have our player idle. Okay, and we can see that collider does not exactly match up. That's because the player is 1 unit wide and 1.5 tall, so we just need to change the size here. And now they match up. So if we press play now, the player will fall down and stop, which is good. Obviously we don't have any input yet, so the player won't actually move around. And that's where scripting comes in. Okay, so again, we're not going to be using Unity's default physics for this tutorial, but I did want to show how you might go about doing it, and again why it's not the best idea. So let's add some objects or some data fields here. Let's see, I guess max speed, that should be a float. And serialized fields, private acceleration. Okay, so basically if okay, let's get this. So the horizontal input equals input get axis horizontal. And we're actually going to just get the axis raw. The difference, well here, in Unity you can define a bunch of different input buttons right here. And we can see we have horizontal already defined. And it's good to use these because there's a default key mapping interface that players can use, and it's built into Unity. But we don't want to use that for or use this kind of thing for our system because we're going to have acceleration built into it. So that's the difference between get access and get axis raw. The get axis raw just ignores any smoothing that Unity might try to add to it. So so we're going to need something. Actually, we don't. Yeah, for the default physics, you can just use the force system. So you'd say, I don't know, force, and then we'll get rigid body 2D. And then we'll get the rigid body here. Okay. And you just say get component rigid body 2D. And then right here, this is rigid body, add force, and so new vector 2. It would be horizontal input times force, and then no vertical input. And this is basically it. I think, well, we don't have any. Oh, I didn't add the object yet, so let's do that real quick. So we got physics player, and let's do one force. And I just remembered you also want to do fixed update for anything that has to do with Unity physics. And that's just how Unity does it. Okay, so nothing is happening. I'm pressing the keys right now. So I wonder, is the force too slow or too low? Yeah, that was it. Okay, and you can see that it actually went through the collider, but that's just probably because the force was really high right there. And also for 2D, you'd want to freeze rotation, so you could just click that. Okay, so now you see it does. And so this is pretty serviceable if you want to have realistic physics. The thing is, in classic platformers, like you can notice that here there's like a ramp up and a slowdown, and in classic platformers there's basically the input, or the movement is very responsive to the input, meaning that pretty much immediately after you take your key off the button, the character would stop moving. And in order to copy that in Unity, it's very difficult to use the default physics. You can try a bit by increasing like the linear drag here, which is basically a friction force. But you can see it made the character's max speed slower, so then you need to go and increase this, which then makes your character slide more. So it's very difficult to try and balance things correctly. So there's some other tricks you can do, but I mean it's just more trouble than it's worth in my experience. But I guess if you are strapped for time, or you want to just prototype something, using the default physics is very nice, because you can see we pretty much got everything up and running already. Okay, but in order to get more responsive controls, we'll use something called Raycasting, which is also built into Unity, but unfortunately it doesn't use the force. So you might think, well, can't you just set the transform position yourself instead of using this force? Well, you can do that, but then the collision system won't work. So that'd be basically like me using these arrows, and you can see I can just go right through that collider. And you might get some weird, it could kind of work maybe, because you can see it pushes back, but what you actually want to do is, like, before you move, you would want to see if you collide with something, and if so, stop right before you collide, and that's exactly what raycasts do. Alright, so we're done with the physics player, but I'll actually duplicate it because we can reuse a sprite, and this will be the raycast player. And raycast method uses all the same colliders as Unity physics system, but it does not need a rigid body. Oh wait, no, you still do need a rigid body. Right, but you have to set it to, where is it? Set it to kinematic, which basically means that Unity will know that this object will move a lot, and so it will optimize the collision for that, but it will not be affected by Unity's physics. So for instance, when I press play, notice that it does not move down due to gravity. Alright, so again, you set the rigid body to kinematic, but basically, besides that, you don't do anything else with the rigid body. And you still use the collider, and of course we'll use the sprite renderer. But we won't need this physics player anymore. Alright, so let's add a new script. This will be the beginnings of our raycast player. Why don't we actually call it an engine? Because, I mean, you might want to reuse this for something besides the player. for an enemy or something, for example. Okay. Now, so we set up the colliders and we did the physics-based player. So right now we're going to work on this raycast box, which will basically take the collider and build points to raycast from. So basically we need to raycast from each corner and then in each direction to see if we ever will collide into something. And there are a couple, well, you can see it's also very useful to be able to know if you're touching something, and that's called a grounding raycast. And so our box raycaster will basically take care of both by making it easy for us to say, okay, raycast against the bottom or any direction on this character. Okay, so first we'll make just a normal class actually. And we'll just go ahead and use the Unity script. So this will be raycast border. Okay, and this will just be a normal class. And we'll have a few objects here, which I'll explain. Okay, so this vector 2 is the raycast direction. So for example, we'd say either left or right, left, down, or up, and that's the direction for the raycast to go, outwards from the player. And then we would want vector 2 origin points. And this basically is where we start each raycast for this side. So simply it'd be this corner, that's about it here. Oh, well, actually, Unity also has something called a layer mask, which you can use to only hit certain objects. I'm not sure if we'll actually use it in this tutorial, but I mean, it doesn't hurt to already include it, because it will be useful, for example, if you want to only raycast for enemies, for example, to see if you touch one and then you can damage yourself. Alright. Okay, so let's get started here. And we'll have so I guess we need to decide what would we send here. I guess vector 2 start and so this would be like the start point, the end point, and then the vector 2 direction, and then something like, okay, well, let's just do this first. Okay, so this is pretty simple, so we just say this, raycast direction equals direction, and then the origin points is simply, how do we do it like this? Start and end. Okay, no, it does not like that actually. Oh, I guess we should also pass the layer mask. Oh, and then of course one other thing we need is the raycast length. I did that wrong actually. It's supposed to be a float here. Okay. And we'll go ahead, this might change. So we can go ahead and build an accessor so we can change the raycast length whenever we want. So then simply let's just have an object here, which would be do raycast, and we can return a boolean if it's true or false. So yeah, I guess we'll start with that. And here we would just return physics 2D raycast. And so what we need to do, a couple of physics 2D, one for each of the origin point actually. So we'll loop through the origin points. So how, yeah, so you can see here the argument, first argument is the origin, then we have the direction, and then the distance, and then the mask, okay, is that correct? The origin, direction, distance, mask, okay. And we can say if we hit a collider, so if the collider does not equal null, then we would return true here. Otherwise it would return false. Now this is not really that simple, I mean that useful, because we kind of need to know the distance to this object. So a couple ways to handle that. Is it we can actually just say do raycast, and instead of turning a bool, we return a float, and so we'd have min distance maybe, yeah, instead of this being raycast border, well, let's see, I think that we might want to use this one to specifically try to find distance to an object. So first, the min distance, of course, is like the maximum, so float max value. Okay, so now we'll need the raycast hit 2D object, which is basically returns the value from this raycast, or the result. So again, if the hit collider is not equal to null, then that means that we actually hit something. And so then we can see, we can set min distance to the minimum between itself and the hit distance, which is exactly what it sounds like, the distance until this hit from the origin. Okay, and then we can return -1 if we didn't hit anything. Oh, actually we need to always return min distance, so I guess. Okay, so I think what we should actually do here is have it, we pass the distance that we actually want to move. So yeah, this will be useful. And okay, let's specialize this object. Instead of just being a general raycast border, this will be raycast move direction. Alright, so, and also, we can see if I add this raycast engine and we create one of these objects. So, private raycast. Let's call this move down. Then we'd set move down to, okay, so we know, and again these values will be like, that's another thing we should do here. We notice that these origin points don't move, but obviously the character will move, so these will be more like offset points. So we kind of need an origin here. So we would call, this is actually an offset. Let's go ahead and rename this as well. And this, that way whenever we call this do raycast, we would pass the object's position at that point. But anyway, so here the start, since this is the bottom, and we know the character is 1.5 high and 1 wide, so that the start would be -1 and then -0.75, and the end is 0.5f, 5, and the direction is vector 2 down, and then the layer mask, we can do this a better way, I think. We'll be able to enter this using the Unity editor. So this will be the platform mask. Okay, and so here on fixed update, let's try and do gravity first. So serialize fields. Let's just call this test gravity. Well, no, we can try and do it. And then we'll have private vector 2 velocity. So on fixed update, we just add gravity to the velocity. Times delta time. Actually, it should be minus because gravity goes down. Okay, and we're just always going to assume that we're moving down because the y is negative right now, so float move down equal, oh, we already have that. Down amount equals move down do raycast, and again we'll give it our current position and then the velocity y times the delta time, and we also need to flip it because, again, remember the raycast is pointing downwards, so but when we're moving down this velocity is negative, which would actually make the raycast check up, because obviously negative makes it flip, so we need to subtract here, or flip this so that way the arrow will still point downwards. And finally we call transform translate, which just moves this object. down amount. And again, this is negative since we're going to move down. Okay. So I'm pretty sure we'll get the object to move now. Let's have a gravity of 8. And the platform mask is everything at this point. Okay, so something obviously is not moving. Did I add the Raycast engine? Yeah, it's right here. Okay, so this is the only problem with Raycast. Is since you have to do it all yourself, you need some better debugging tools. Alright, so let's go ahead and add it. Okay, and one easy way is just to create a little helper function here. And instead of calling this, we would call this Raycast. So we have vector 2 start, vector 2 direction, float, length, and layer, mask. And then, so Unity has a nice little debug called debug draw line. And so start, and then the end point is start plus directions times the length, and then we'll just have the color be blue. And then we can actually return the real Raycast physics 2D Raycast start direction length mask. And now we should see blue lines up here. Okay, but we don't, so that means that either that function is not being called, or we have some other bug. Okay, so let's make sure this fix update is being called by using debug log velocity, and then it'll print out the velocity every frame. Okay, so that is clearly working. So that means let's print out the down amount. Now I'm expecting this will be 0 every time. Oh, it would definitely be 0 if you just tell it to log 0, but okay, right, it is 0, and so that means we're having some kind of bug. Okay, so collider does not equal null. That means we hit something. So we're getting a min distance. That seems okay. So let's do some debugging here as well. Debug log string format Raycast start in 4. So this will print out the start, the direction, and the length. And let's see what that gives us. Okay, so start and down. Okay, so the length is 0. So that is the problem. Oh, and it's because I'm using this old Raycast length variable that we don't need anymore. Now we should move downward, I'm pretty sure. Okay, we're still not, but we can see... Okay, well this doesn't actually tell us what the min distance changes to. Okay, so let's debug, log, hit. Oh. No, that's right. Yeah, because we only change this if we actually hit something. Yeah, okay, well let's just see what this prints out. Hit, and then we'll have hit dot distance. Okay, well that's interesting, because we're obviously not hitting anything. Oh, but now we can see that the raycast is working. Oh, you know what? Maybe okay. This, yeah, I didn't think we'd have to do this just yet, but this does show a problem. I bet you that the raycast is actually hitting the player collider itself. Now, one way to fix that is if you move the raycast just slightly inside the collider, Unity will not collide with the colliders that we start inside. So that's one thing we need to do for sure. So we don't need the object there, but here while we create it, we'll pass a vector to, or probably a float. So we want to have a parallel offset or inset, and then a perpendicular inset. Did I spell that right? It's perpendicular. Doesn't look right, but no, okay, that's good. Okay, and the parallel will be parallel to the start and end points, and so it will tell us how much we'll inset this way, and then the perpendicular is off. I mean, it's obviously off perpendicular, so it'll be how much we move this way. Okay, and so parallel inset, this would... So, vector 2, parallel, is start minus end, and then the perpendicular or maybe, well, we can't find this. Like, you can find a way to get a way to find any perpendicular vector is just to flip, do something like this. You take the negative of one of the sides and then flip the x and y, but we won't know if this is on the inside of the collider or not. So I think we should probably actually do vector 2 here. So that way we can just add and subtract. So it'll be plus parallel inset, and plus perpendicular inset, and then on the end we'll subtract the parallel inset and add the perpendicular inset. It'll be a little more work when we create this object, but I think it'll be the right thing to do. Okay, so platform mask, parallel inset is... Okay, so we start on the negative side and go to the positive, so that means we want to go right. length. And then we'll have the perpendicular inset length. And again, perpendicular, since this is down, will be up, because we want to make sure we're moving inside the collider. Okay, so now when we play, first we gotta set those values. So parallel, well, I'll make it pretty big at first just so we can see. Okay, and we can see they start inside. The weird thing is the length is now offset, so we need to make it longer so that when we pass the length of 0, the raycast would go right here. So it does, this needs to keep the add length, and the add length is simple. This is a perpendicular inset length, or magnitude it's called. That's just the length of the vector. So here what we would do is, so we need to add the add length here, and we have to subtract it right here. Okay, now we can see that even though the raycasts start here, when we pass 0, the raycast actually will go to right here. Okay, and now it's actually working, but it seems like we got some of the directions mixed up because gravity is actually making it fall upwards. So I guess is down, I'm pretty sure down is not negative. Yeah, down is negative, so I'm not sure exactly why that is happening. Let's get rid of this, and then I'll look closely at the log down amount. Okay, so it keeps on saying -2. Maybe it still is colliding with the player. Okay, well that's not too difficult to change. So that now we'll actually use the layer mask. So we go into physics, not physics 2D. You go to edit, project settings, tags and layers, and so I already have one set up for platforms. So we'll just have one set up for the player. And I think if we tell the platform mask to only collide with platforms and then set the layer here to platforms, then it should work. Yeah. And then you can see when we are on the ground, gravity's like we don't move forward anymore, even though the gravity vector is still moving. You can see it keeps on trying to move us faster and faster. That will be something we need to fix when we move on to jumping. Well, actually, when we figure out how to handle grounded. So let's do that now. So we'll want to have another of these, except this one will be raycast check touching, and it'll be almost the same, except this time we'll have a set length, and it's just going to be checking to see if there's any platform close to us. Okay, so we still need the parallel inset. In an actual project, you would want to somehow move this code out somewhere separate so that you wouldn't have the same thing in every object, but just for simplicity I'll leave it like this. Let's see, so floats, let's call this the check length. And we can actually bake in this add length into the check length, so we'll do that now. So the check length is the perpendicular inset plus the check length that were sent. And I guess to remove confusion, let's just call this array check length. Okay, and now the raycast here is a little different. Let's make this color red, just to differentiate. So hit, and we don't pass a distance, but we'll still pass the origin. Now all we have to do is that if we hit a collider, we'll just return true, because we only care at this point if we hit something or not. Okay, and we'll use this to tell when we're touching a platform, which is useful for many things. So private raycast check touch, this will be ground down, and I'll copy this because we can reuse it. Okay, we'll still use the platform mask, and it wants a length, so let's go ahead and add another variable here. Private float ground test length. And we'll just pass that here. Okay, and then so a couple ways you can do this. Well, basically for now we'll just say if ground down do raycast transform position. So if this returns false, then that means that we're not touching anything on the bottom, and we'll add gravity to the velocity. Otherwise, we'll set the velocity.y to 0, just for now. Okay, now we can see it stops, and the blue raycast, which is the movement, does not keep growing farther. So that will be useful because obviously gravity acceleration does not keep increasing if you don't actually move. Alright, so we have velocity. Now we need to add basically these moves and grounds for, well, we may not need a ground for every direction, but definitely we'll need movement. Okay, and let's add, oops. So we got left, right, and up. Okay. So for left, start at the bottom and go upwards. So the vector is left. So platform mask, except parallel now is up and perpendicular is right. Okay, and so for move up, basically flip everything here. direction is up, perpendicular is down, and then for move right, oh, I thought it would help me out there. The x's are both positive. Direction is right, parallel is up, perpendicular is left. Okay, so now another way we can do this. Okay, let's have vector 2 displacement, which is a fancy word for movement. Alright, so if velocity.x is greater than 0, then we'll do move right, velocity.x, else if velocity.x is less than 0, then let's move left. Of course we need to set displacement.x to whatever it returns here. X equals negative, move left, do raycast, and negative velocity x, time, delta time. So now we can do the same thing for up and down. Of course, except you want to replace all these x's with y's. And this is move up and move down. Oops, I didn't want to do that. And now we just change this to displacement. Okay, so let's see how this works now. It should be exactly the same, and it is, thankfully. Now we can see also that there's only one red line, and that's just the grounding test happening every frame. Alright, so now let's add a little horizontal movement. So we have gravity, let's add private float, horizontal acceleration, and private float, horiz max speed. Okay, I'll leave this for now, although we might change it. Another easy way to do this would just be that if the velocity is clipped here, then we would reset the velocity value to 0. That might be a better way to do it than having to check if we're grounded, but we still will need to see if we're grounded to know if we can jump or not. So, and we'll get to that in a second. So let's see, float, horiz, input. Again, we'll just use the same thing that we did back for the physics player. Get axis, horizontal. That's it. Except we should do get axis raw, because we don't want any smoothing. Okay, so now velocity.x, we add the horizontal input times the acceleration times time.delta time. And if velocity.x, we should do, and here we need to use mathf.absolute value to make sure that it takes into account both directions, negative and positive. And if this is greater than the max speed, then we need to clip it here. So we set velocity.x equals horizontal max speed. Alright, times, so again, we need to take into account both left and right, so we can just do the sine of the horizontal input. This is one way. Another way to do it is also the velocity, just say velocity.x equals mathf move towards. And this is a really nice function that Unity has, and it basically does exactly what I did here. It adds a value but clips it. So current, and then the target would be horizontal max speed times the mathf sine horiz input, and then the max delta is just the horizontal acceleration times delta time. So I don't know which one of these is easier, but you can use, I mean, they're basically the same. I'll go with this top one because it's more spelled out. Okay, so now, oh, I need to set the acceleration value in here. Yeah, I accidentally kept that at 0. So the horizontal acceleration is, let's see, let's set it to 1 NC, and the max speed, do 3. Okay, so it kind of works, but actually, now I was thinking about it, we don't have like deceleration, and it's also very slippery, which is the whole reason that we wanted to do something else. Alright, and give me just a second, I'm going to get a drink of water. Thank you for that. Just my throat was being pretty dry. Okay, so, alright, what we're doing, we need, so this is one way to do it, but actually, since we need to kind of slow down, using this move towards might be better. So, change this back, and so we want to move towards the velocity. That's not right. We want to move towards, oh no, yeah, this is current and this is the target. So it's the horizontal max speed times the input, which will be 0 if nothing's pressed. And then this is the acceleration. So yeah, this should work well. Okay, so sine, okay, I guess it returns positive then. So how I'll do it is if not mathf approximately horizontal input is 0. So if horizontal input is not close to 0. Then we'll do this. Let's make this a little clearer. So that's false. Otherwise, we'll do the same thing except we'll move towards 0 explicitly. Alright. So now we can move back and forth, and you can even see here the little blue lines for our raycast. But we're very slippery, which is, again, what we didn't want to do. And maybe we can fix it by making acceleration a lot faster. Still a bit slippery. Get it even faster, but find that there are better ways to handle it. To make it a little more, because you do want a little slow down. So let's have that at 12. So there are a couple ways that you can try and fix this. So we can have the acceleration, and then horizontal stop acceleration, which speed up accel, and we'll have speed down acceleration. And having two separate values here can help a little bit. So let's see what that does. Okay. So for example, speed up would be 12, but then speed down maybe is much faster. So that's looking better. But you can see, I guess you can't really tell exactly what I'm doing here, but it takes a while for the game to actually respond to my changing directions because, well, obviously the velocity kind of sticks around for a little bit. So a good thing that I like to do is that if the player moves or the input is in a different direction than the speed, is the game kind of just like flips the speed right away. And this is, so we have the max speed, and I call this the startup speed. Private float horiz start. So it's kind of like when you first start running, you kind of start a little faster because I guess you have the potential energy from your feet to help push you. So how you would do this? Okay, so let's see. So I think a good way to do this would be we'll have an int wanted direction and an int velocity direction. And by inspecting if these match or not, we can tell exactly what we need to do. So, horiz input, well actually let's make a little helper function here. Private int get sign, and we'll have some value here. If value is greater than 0, then we'll return 1. Now we can't use Unity's built-in math sign because as we saw earlier, it returns +1 when the value is 0. We actually do this a little different because due to rounding errors, you need to test for 0 first. Otherwise you'd probably never get it. And then else if it's positive, then return 1, otherwise we know it's negative, so -1. So again, if value is close to 0, we return 0. If it's greater than 0, we return 1, and otherwise negative. So get sign, horizontal input, and get sign, velocity dot x. Okay, so if wanted direction does not equal velocity dot direction, then we want to do this startup speed, which I think I'll rename to snap speed because that explains a little bit how it's going to work better. So in this point we just set velocity x outright to the snap speed times the wanted direction. And again, if wanted direction is 0, then I guess we should actually do that. If wanted direction does not equal 0. Otherwise we'll use our deceleration, or excuse me, speed down acceleration. Sorry, physics people. So okay, so in any other case we would just speed up. So velocity dot x equals, okay, don't need this sign anymore because we have that already. So wanted direction. Alright, and then if the wanted direction is 0, then we just speed down. So this should be a little more responsive. Let's wait for it to recompile. We've got the snap speed. Let's set it to 1 and see how that looks. Okay, we can see, yeah, it goes a lot, it's a lot more responsive, but it's still smooth. It has a little bit of acceleration. And maybe we can even slow these values down a bit because the snap speed helps mitigate the slowdown that you would expect normally. Yeah, I'm starting to like this. Okay. Of course, you can play around with these values until you find something you like. But I think that last test was pretty good. So I think now we've got the raycast and did collisions, gravity, and horizontal movement. So let's move on to jumping. Okay, we have an hour left, so we should be able to do this for sure. Okay, so jumping input, I know right away can be a bit of a problem when you're working with these type of things, so I'm going to just start off with a good little trick. So okay, we'll have private jump want timer. Okay, so due to the way the input is updated, which is on the update frame instead of this fixed update, you don't want to ever do something like this, which would be if input get button down jump during fixed update, because you could miss this event. And get button down is different because it only returns true on the exact frame that you press a button. So since fixed update is not necessarily called every frame, you could miss it. So you definitely always want to check for that kind of stuff in the update. And so what I'm going to do is if the button is down, then we call jump want timer and set it to, I don't know, let's have serialized fields, private float jump want leeway period. Let's change it to input. And this should be just a small fraction of a second. Also, you might notice sometimes when you like if the character was not actually touching the ground but the player still pressed jump because they want to jump, it can be a little annoying because the game will not think you can jump at that point. So instead what you would do with this system is it gives a little bit of leeway before the game will just ignore that input. that makes sense. I guess we'll see it momentarily. Okay. So yeah, we got the input. That's all good. Oh, one other thing. This might not be much of a problem in this game, really. But let's add... But we can see... Like, when we move over here, you technically still have a bit of momentum even though you hit the platform. Oh gosh, I just noticed it's very slow. Let's speed it up. Of course, now the snap speed needs to be faster and everything. And acceleration. But anyway, I think what we'll do for that is make it, like I said before, we should really set the velocity to 0 at this point. Okay, but so I guess how I'll do that is let's say vector2, so wanted displacement equals velocity times time dot delta time. Okay, so if mathf abs displacement dot x, well, we don't have to do mathf abs, we can just do something like if mathf approximately displacement.x and wanted displacement.x is false. So if we got clipped sometime, then we would want to set the velocity.x to 0. And same with y. And this is pretty much just what we did here for gravity. We might not even need the grounded test for anything besides jumping. Okay, so yeah, we can comment this out then. And then here where we call this, we can just call wanted displacement. Because we already multiplied by time, delta time, so no reason to do it again. So let's just do a sanity check, make sure it works still. And it does. We can see the gravity vectors are not growing because it's being deleted every frame. Or not deleted, but zeroed out every frame. Alright, so that's good to see. We still have, we can move gravity as it is. Okay, so back to jumping. So what we need to do here is if ground down, do raycast. So if we're grounded and jump want timer is greater than or equal to 0, which we need to count down this timer right here in the update. So that means we can start a jump. So we can just set the jump on timer to 0 so this won't be called again. So basically how jumping works, well, again, jumping in physics and platformers is not, how should I say, physical like how it would be in the real world. In the real world you would just apply a force at the beginning and then you jump in a smooth arc, but in platformers you want to jump at different heights depending on how long you press the button, for example. And it also needs to kind of And there's no gravity during that point either. So how I would do this, okay, we'll have this jump state, so none, and then holding, I guess that's it, I think. So we'll need another timer here, which will be the jump hold timer. Okay, and we'll also need a boolean here to see if the jump input is down. Okay, so what I'll do, this will be start jump. So we change private jump state. Okay, so jump state. Hi Chocopix Ultimate, thanks for stopping by. Equals holding, that means we'll start the jump and we'll set the jump hold timer to 0. Let's change this to the jump start timer. It's a little clearer, I think. Okay, so if jump input down. Okay, so also this only happens, we can go switch jump state, because again, we obviously only want to start a jump if the jump state, if we're not jumping at this moment in time. But then if, not none, if we're holding a jump, so if not jump input down, that means we want to end the jump. And how we can do that, well, we just set jump state to none at this point. And then we would do some logic to change the exit velocity of the jump, which we'll do at this point. Okay, so but also gravity is ignored during this part. So let's see, if jump state equals none, then we'll do gravity. Okay, so let's see. I've got no chat bot. I'll be happy to answer any questions though if you've got any. Okay, so what's the next step? Oh, right. So serialize fields, private float, jump, start speed. Okay, and private float. So let's just do it simply first. Again, so jump input down equals, let's do it this way actually. So jump button equals input get button. What's my game about? Well, today I'm just making a 2D platformer, just kind of as a tutorial. Right now I'm working on jumping. So if jump button is true, but it was not true on the last frame, then that means it's basically the same thing as using this input get button down. now I'll cache this jump button value. Okay, and so here, start state hold, and we could just set velocity.y to the jump start speed, and jump hold timer. Okay, so let's see how this looks. Yeah, kind of training. Okay, so I'm not jumping, I'm pressing space. Let's see, is that the Unity input for jumping? Yeah, they have jump right here. Okay, so yeah, it is space, but something is not working, so let's check it. Oh, I bet it's because I didn't set these values, of course. Okay, so let's have the leeway period on a quarter second, and the start speed will be something like 8. Which I think will be kind of slow, but... Okay, so you can see I can jump, and whenever I take my finger off, it will stop. Right now you can continually jump as high as you want, which is probably not what we want. So obviously we need to have a max jump hold period. Private float jump max holds period. And at this point we'd say if jump input down equals false, which means we stopped it early, or the jump hold timer is greater than or equal to the jump hold max period, then we would stop the jump. Oh, except I forgot to set the value. So let's set maximum to a second. Okay, so you still jump pretty high. I wonder... Let's set it slower to see if it's a bug or if I'm actually able to jump that high. Okay, so yeah, now it definitely stopped it. Since the gravity is really low, we should probably turn that up. Yeah, that looks better, I think. Okay, and we already have a bit of a nice variable jump heights. But I found another trick to make it even more responsive, which is needed especially if you have higher jump speeds. Because right now I think this is the minimum we can jump, and that's kind of high, so... Okay, so we have the start speed, and we'll have serialized fields, private float, jump, min speed. And so how you do is when you stop, basically based on how long the player held the timer, you kind of slow down the jump speed. The best way to explain it. So velocity.y equals, we use this lerp function, which stands for linear interpolation, but it sounds much more complicated than it is, don't worry. Velocity y. So basically it means you start at this value and you end at another value, and the game picks some value between them depending on what the distance between 0 and 1 this final argument is. So the start here would be the jump min speed, and then jump start speed. And then our percentage value is the hold timer divided by the max hold period. Okay, so let me write this out. Another way to do this, the lerp function, if I wrote it myself, is you take the percentage of this and then you'd set velocity y equals jump min speed plus the difference, so jump start speed minus jump min speed times percentage. And this is the same thing as this lerp function. So I'll leave that there, so hopefully that makes sense. Again, if anybody has any questions, I'm all ears. So now that I did this, I think that the jump will be a lot more responsive. So now I'm gonna basically just tap the spacebar and see how high our jump is. Yes, that's pretty good, and then our max jump, of course, goes really high. So a good variation there. If we lower the hold period even more, yeah, so you can get a big value depending on how long you hold the spacebar. That's what you want. You want to give players as much control as possible. I'm trying to understand Chocopics. Okay, don't feel bad to ask anything. That's what I'm here for. Okay, so now you can see our movement speed is really slow compared to jumping. So let's fix that before we go on. How's that look? Okay, the snap speed is a little weird at this point, so let's see. And I'll make the acceleration. Yeah, this looks pretty good, I think. Okay. Oh, I didn't save the values. Let's see if I remember them. I think this was 20 and 16. This is a neat little trick in Unity. So if you do what I did and just edited values while you play, if you exit the play, Unity will actually remove your values, but one way you can save them is you click this gear and call copy component, and then when you exit play mode you can just paste component as values, and that way it'll save everything you changed. Thinking of getting the coding, it seems interesting. Well, I really enjoy it. Basically make anything you want, it's pretty fun. Okay, so we've done jumping. Okay, so now we've got these random platform things, but let's take a bit maybe and add some animations to the character. So we got this animator, and I went ahead and set this up. So what we'll do, we need the private animator. Animate equals get component animator. And okay, so now we know when we're jumping, right when we jump, we want to start the jump animation. So we say animator play jump. Okay, and then the other ones are a little bit different. So there's a couple other ones. We have idle when we're not moving horizontal. Okay, so how we can do that is if wanted direction equals 0, then we can call idle, else move, and then the last thing is falling. So here it'd be if velocity dot y is less than 0, then we'll play fall. A couple things to keep in mind. And I actually think that the way we handle this is probably not the best. Is you'll see they kind of will overwrite each other. I'm actually curious how this will work. Yeah, you can see that it's trying to do multiple things at once. And yeah, it doesn't look very good. So how I would fix this... Okay, so yeah, if we're jumping, we want jump to be the highest priority. So if jump state equals jump, yeah, that's holding, then we'll say nm play jump. And okay, so if we're not jumping, then we can decide between the other three. So we need to know if we're grounded or not. So let's say bool grounded, which basically means we're touching the ground again. Move that out here. Okay, so if grounded, so if we're grounded, then we can do this horizontal movement. And then if we're not grounded, then we'd either play jump or fall based on if velocity y is less than 0 or not. Okay. I think there might still be a problem here, but let's see how it looks. Okay. Okay, so one thing is, the movement animation is supposed to be looped, or it's supposed to have a couple frames. Oh no, it is doing it right, okay. It's just too slow. Okay, so one way we can fix that is we go in the animator and go to move and set the speed much higher. So now we can actually see it. Of course, another thing is the character does not change facing direction, so let's see. Order of the scripts matters a lot, right? Well, yeah, mostly because we want to make sure that we only update the animation after everything else is up to date. So in that respect, it's important. Hi Ardatin, I'm doing a platformer. I'm trying to make, well, Unity's default physics engine isn't very useful for platforming. I demoed it earlier because everything is too floaty and slidey, if that makes sense. So I'm trying to make a much more responsive platforming engine. So I think this should be more. And let me see. So, alright, so I was working on, we need to flip the sprite basically when we're moving left. So we gotta get the sprite renderer. And equals get components, sprite renderer. And all we have to do here is basically anytime the wanted direction is less than 0. Oh, actually we do it like this. So sprite renderer flip x equals wanted direction less than 0. And we can see... Okay, well no, this won't actually work, but I'll show you. So it does flip, but the problem is when we stop, the character always turns back right, which is not really what we want to happen. So we need to... Basically, if wanted direction is 0, we just don't change this. So if wanted direction equals, or does not equal 0, that's the only time we'll update this flip. Okay, and now we can see the character will stay facing left. so I want to add a couple sound effects maybe. Let's see, how much time do we have left? Oh, we still got plenty. Okay, so I have these three: start, move, jump, and land, and I'll just drag these up here. Oh, that did not work as I wanted. So I'll drag them, I guess just empty. Okay, this creates a new object. So I'll parent them to the camera because the camera has the audio listener. Okay, we don't want it to play on awake. And they might be loud, I'm not sure. We'll see when we play it. Okay, so let's get serialized field, private audio source. So jump, sound effect, land, sound effect, and start, move, sound effect. And these will be pretty easy to do because we already know right when we start jumping is right here, so we can call jump, sound effect, play. And then here is when... Okay, well what we actually need to do is we need to check when this grounded value changes. So we'll need private bool last grounded. So if grounded does not equal last grounded, well, that's not actually what we want to do. We want to see if we're grounded now and last grounded equals false. Then we call the land sound effects play. And we'll always update the last grounded value. And final one is start movement, which we basically play whenever we do this snap speed. So start move sound effects. So yeah, not too difficult here. And I'm just showing you how you might go about adding some flavor to your characters. I know this doesn't really have to do with the physics of it, but I think it'll make things a lot nicer to work with. Okay, so I hope you guys can hear that. It's a little loud, so let's change these to... okay, and I think the jump was actually pretty good, but I'll turn it down a little bit. Yeah, that's better. I think landing is still a little loud, so let's turn it down. Yay, now sound is not all silent. Okay. Gotta re-update that. Okay. So now on this list, I have some of these extra like physics objects, because Unity provides these things, but obviously if you're making your own physics engine with the raycast collisions, you need to rebuild these yourself. Okay, so one thing you might want to do is you want a platform that you can actually jump through from the bottom. Like, lots of platform games have this. Alright, just doing a little bookkeeping. So let's change this to tiled, and we'll have the width. Let's change it 5. Okay. Yeah, thank you. Okay, so now put it right there. Okay, and we'll put another. Oh no, this is fine. Let's do. We'll need an edge collider. And again, the green. You can kind of see the little green line right at the bottom where my mouse is. That's where the collider is right now. So let's nudge it up 0.125. Okay, that's too high. So 0.75. Where is that? When do you think I'll be finished? This tutorial will end at about 6. Oh, did it? I guess that's too small. 0.75? Oh, there it goes. I think it's actually 0.65 is the correct value here. Yeah, so you can see it's almost exactly on the top. Well, 6 p.m. Central Time for me, so in about 20 minutes we'll be done. I always forget about time zones, sorry about that. And I'm going to try and see how much I can finish. Okay, so right now this won't work. We can see why. Oh, it's not a platform tag right now, so he just jumps through it. But I was expecting to hit my head on it like that. Okay, what we actually need to do is just move. So we can add, there's a lot of ways to do this. How I'll do it is we'll add another mono behavior that we can put on that collider, which will be move through platform. And I don't know if we have to have any information on it really. Okay, and how this will happen is if move through platform. Oh wait, so say move through platform equals hit.collider.get component. So I'll just call it MTP. So one thing we do need is we'll need like public vector2 so how do I do this? I guess permit direction, which is the way that will let colliders move through. Okay, so if raycast direction equals mtp.permit direction, then we would just ignore this. So I don't know if this will work right away, but let's try it. Okay, the permit direction is up. Okay, so something wrong happened. Oh, I needed to, yeah, again, if mtp equals null, that means it's not a min distance. I mean, it's not a move through platform. Okay, so let's see. Oh, it does let me through, and well, it works perfect. So that is one good way to do it. Another way, I'm trying to see if it can trigger, but I mean, you could have a problem where one of your sideways raycasts hits the platform and then it would stop you. But it seems like it's okay. Yeah, so cool, that was pretty quick actually. But if you are having that problem, what you can do is do something like vector2s have a dot product, which is good to use to find the angle between two vectors. So maybe I'll go ahead and do that. So public float dot leeway. So we raycast direction, or I think it's vector2 dot raycast direction is less than the m2p dot leeway. And I think I forget. Sorry, my mind went blank. Dot product. Yeah, if they're parallel, is the dot product 0? Or is the dot product 2 parallel? Dot product is positive if they're an opposite. Okay. Okay, so it's 0 if it's perpendicular. So we want to have greater than or equal. Something like that. If this doesn't work, we don't need to go through trigonometry and vector calculus, but okay, so that. Alright, so yeah, I don't want to mess around with the math, but I mean, if you want to do something like that, it's a good way. Okay. So yeah, just verify this still works, correct? Okay, what did I do? Permit direction. Oh, I got it backwards. That was probably the problem. Yeah, because if this is false, so it's less than dot leeway. Yeah, so if it's less, that's when we do this part. Yeah, so I did. Sorry about that. Probably confusing everyone. Yeah, there we go. Okay. Alright. So good. We've got a few more minutes. I think we can do moving platforms. So let's do another... Let's create another object here. Obviously, moving platforms can cause problems with this, but I'm just going to do something simple. And the width is 8, height is 1, and I gotta update the collider. Okay. So first let's create a class real quick just to move the platform around. So platform mover. So serialize fields, private, vector2 direction, serialize fields, float, radius, private float, period, and that's it. Okay, and basically all we'll do here, I guess I need to get the center. Vector2 center and private float timer. And the center equals transform position. And so transform position equals new vector2. Oh no, that's not what we'll do. We'll do direction times mathf sine of the timer times radius. And multiply the timer by time dot delta time. Okay, this isn't the pair, this will be the speed times speed. I guess we can add the time speed right here. Okay. So as you can see, when we add this, the platform will move back and forth like this. Platform mover. Right, let's have a radius of 6. Oh, that's probably up too much. And speed, let's see how that looks. Okay, that's really fast actually. Yeah, that's more what I was thinking. But I want it to go off the screen a little bit. Okay, I think I forgot to add the center right here. Okay, yeah, that's good. Better. Okay, yeah, so I want it to move off the screen a bit. And we can see it's not very good right now because the character does not actually move along with the platform. So it's kind of weird. But good thing is we do fall off like that, so it's, we know that at least gravity works. So what we need to do... Okay, so we need to know pretty much the last collider we hit. So private collider 2D. This would be last collider. Okay, and technically we could hit 2 separate colliders because we do 2 separate raycasts. But I'm not going to take that into account just yet. Especially since we only have about 10 minutes. Okay, and also at the beginning we need to set this last collider to false. Actually, we shouldn't do this in the movement, we should do it in the grounded. Okay, so yeah, in this raycast check touch, that's what we'll do. So bool, do raycast. You could even just return the collider right here. Collider 2D, return, hit collider, and then null. Okay. So back to, where is it? Raycast engine. So let's get the collider 2D. That's not what I wanted to do. So standing on equals ground down. And so grounded equals standing on is null. Okay, so really all we need to do is if we're standing on something, we need to also change our velocity to match its change in velocity. So let's see. Private vector 2 last standing on position. Okay, so let's take care of this down here. If grounded, then last standing on position equal, we'll do this. Okay, so we need a little more actually. Let's do private enum, standing, state, nothing, touched, stuck. And the reason we have to do this is because the first frame that we touch something, we won't how do I say it? We don't move any because we didn't know its position last frame. So we also need the collider 2D last standing on. Okay, so switch stand state. I guess we didn't technically need to do that, because if standing state nothing, then we know that we're stand state stuck. Last standing on pose equals standing on transform position, and last standing on equals standing on. So another thing you'll need to do is if the standing on changes. Yeah, so we can't just use this pure switch actually. So if stand state equals nothing, or last standing on does not equal what we're currently standing on. Okay, and then else if stand state is stuck. Okay, what's it? I'm missing a parenthesis or something. Oh, right here, it's a bracket. There we go. Okay, so if stand state equals stuck, then okay, so the problem is we need to do this before, I think, because we add the change to the wanted displacement without multiplying by delta time. So wanted displacement plus equals last, oh no, it's a current, so standing on transform position minus last standing on position. Okay, we can move this down here actually. So otherwise we can set the stand state to nothing. Do we actually? I could probably simplify this, to be honest. So if standing on does not equal null, and then last standing on does not equal that, so we can change this to happen only if the last standing on equals standing on, which means we have 2 frames standing on this one object. Oh right, and this is complaining because I have to cast it to vector 2. Okay. I can move that out there. Alright, so that makes things a little simpler. So we can get rid of this standing on state. I feel like saying standing on too much. Okay, so let's see if this works. Alright, so when so something is weird here because it thinks I'm jumping. What did I do? So grounded equals standing on, oh, this is opposite. Everything looks good. And when I stand on this, nothing happens because it's not changing position. Oh no, but unfortunately that's not working. Okay, so let's see. If we change this to debug, we can see all the private variables. And we can see it's standing on bottom platform. And it does have the position. It is changing, but for some reason that's not affecting its velocity, so... Alright. Oh, okay. The reason I think is because we checked the velocity. Excuse me. But we should actually check wanted displacement. See if that was the problem. Okay, good, it does work. I wanted to see if... Okay, and then we get stuck against the wall like that. Perfect. So the one problem is, I don't know, it's kind of hard to tell, but the velocity is not transferred when we jump off of a platform. Can I do that real quick? So I guess how we do this, we'd say else if standing on is null, which means we've hit the air. Then we want to add, like there's a difference. Okay, so I guess we'll need one more value here. So private vector to last standing velocity. Let's call it standing on velocity. Okay, so last standing on velocity equals technically, I guess this isn't velocity. Yeah, it is. It's a change in the frame, so whatever. So if this is null, then we want to add this to our velocity. So let's see. Velocity plus equals last standing on velocity. And then we'll just add this wanted displacement. Well, this isn't exactly correct, is it? So, okay, so this change in position, which is the velocity, but it's not based on time, this is based on the frame. So how would I transform that? Maybe I guess we divide by delta time, which is a bit strange. But let's see how that looks. I mean, you might have some problems with this, but I just want to try it out. There's no problems there. Let's see what happens if I walk off. Well, it's not too bad. Well, I guess it is, it's not really that noticeable, but I mean, it wouldn't be. I wonder if I made the platform move a lot faster, it would be noticeable. Let's try it. I can turn off. Okay, so speed, let's change it. Okay, that just knocks me off. To jump on now, I think. Yeah, see, you can see the character, like, that's a nice effect actually, I wasn't sure that would happen. Okay, and there the momentum definitely affected me, I could tell. Can I get back up there though? I'm just gonna cheat. Interesting. Alright. Well, I guess I probably need to wrap it up now. If anybody has any questions, I can answer some real quick. Or any suggestions for next Friday, I'll do another little tutorial like this. I hope everybody did enjoy it. It's kind of nice to take a break from the long games, so that way it doesn't matter as much what I've been working on for the past week or so. But yeah, again, thanks everybody for watching. I'll be back. Well, I want to start on the weekends doing like a game design analysis of games, and we'll actually play a game, so I'm not going to be able to probably tomorrow, but maybe Sunday. And then Monday I'll be back at 5 Eastern with my old Pokemon Fire Emblem strategy game. I'll be working some more on that. So again, thanks everybody for watching. Feel free to follow. Oh, thanks Chocopix, I just noticed you followed, I really do appreciate that. But yeah, and you'll be notified when I go live next, and also you can follow my Twitter for the same reason. And feel free to message me with any suggestions for the next Friday. Alright, okay, I hope to see you later. Thanks again for watching. Bye-bye.